Given the radius 3 units and the center -2, 4, find the equation of the circle. Of course, having radius 3 units and the center -2, 4. So please plug it in and tell me what to write. Very good. Everything squared plus -4 everything squared equals? Very good. This is the equation of the circle passing, with the radius of 3 and the center of -2, 4. Any questions on this? Any questions? Please.
Changed because
-2, of course. Right. So when we plug it in, when I plug in -2, negative in front of -2 changes into positive. Here is a second type. Oh, let's also graph this. Let's suppose we're asked to graph this circle. So here's how we do that. I will have to start with the center of the circle, which is -2, 4, right here. And then I create 4 points. So I have the center of the circle. I create a point 3 units away west, 3 units away north, 3 units away south, and 3 units away east. Why 3 units away? Because the radius is 3. So here's 1 point, 1, 2, 3, the next point, 1, 2, 3, the next point, and here 1, 2, 3, right here. Yes, make me happy and say that this is a circle. Of course it's not. It's far from being perfect, but that's what it is. Now, what if I ask you to determine the domain of the circle and the range of the circle? Can you determine the domain of the circle?
Oh.
Yeah, you can. Of course you can. So what is this?
-5.
Excellent. And what is this?
1.
That's it. Can anyone give us the range of the circle?
One 7.
1, comma. That's it. Great job. Here's now the second possible question. Here's number 2. Given, any questions, please? Any questions? Given the equation, give me an equation. Any equation you want, of a circle, of course. Thank you for your contribution. Find the center and the radius. Can anyone identify the center for this circle? And the radius? -3, -2. And the radius? Perfect. Any questions? Any questions? Is this okay? Yes? Is that okay, everyone? Okay. The third one, however, the third type, I cannot make up on the spur of the moment. My apologies. We can choose, and I let you choose. On page 332, any problem from 53 through 64? I promised a problem like this a long time ago, and you'll remember when. Anyone?
X squared plus y squared.
Which problem?
Oh, 63. Sorry.
You said 53?
63.
63. Allow me to choose a simpler one before 63. So,
Okay, is that the choosing one?
because, no, we are going to do 63's second problem.
Okay.
Because I need to start slowly. I would like to choose 58. So after 58, I promise we'll do 63. So x squared plus y squared. You'll see in a moment why and what's the difference between the two. Plus 12x minus 6y minus 4 equals 0. Let me read the question. I don't want to read the question. I want to make up the question. I'll tell you why. Is this the equation of a circle? The answer is no clue. And that's the correct answer. No clue. And here I'm going to say this. If somehow this equation can be presented like this, then it's a yes. If I cannot present this equation like this, then it's a no. So I have no clue at this point. Can I change that into something like this? Maybe. So what do I have to do? Just compare this first form and this form. What do you see here? Yes, I see completed squares. One with a number and just x, the other one with whatever number and just y, and here a number squared. And of course this must be a positive number or 0. If it's 0, it's not a circle. So what we have to do is, that method that I said out of 4 methods for solving quadratic equations, I said one of them, no, it's used for something else. Completing the square. So we have to complete the square. So this is one of the reasons why we studied completing the square a month ago. For this. Basically not for solving quadratic equations, because as you know, complete the square is not enough to solve a quadratic equation. You still have to use the square roots, right? It alone does not do the job. Okay, perfect. So then I have x squared. I have 12x. Please tell me what I have to add to both sides to complete the square. Yes, because it's 12 divided by 2 is 6. And when you square 6, you get 36. So this and this and this. Yes, completing the square. The middle coefficient, you divide that by 2, you square that answer, and you add it to both sides. I know, it's been a month ago. It's always the case. It happens to me too. I get to I don't know, in something I study at chapter 10, and I forgot chapter 2. So I have to go back and review. So believe me, I understand. So complete the square method is middle coefficient divided by 2, get an answer, square, and that's what you add to both sides. Middle coefficient is 12, divide by 2, we get 6. 6 squared is 36. So then these 3 terms are x plus 6 squared. Done. Let's go back and complete the square for y. What do we have to add to both sides and not Benny? I have to ban him before he even starts thinking. So we have y squared minus 6y. What do we add to both sides? Say it again. Okay, negative 6 divided by 2 is? Negative 6 divided by 2 is? No, negative 6 divided by 2 is? Excellent. I know it doesn't matter, but negative 6 divided by 2 is still negative 3, and we square that. What do we get? Excellent. So now this and this and this are here. Y minus 3, everything squared. There is a 36, there is a 9, and there is a negative 4. So 36 plus 9 and plus 4. Move to the other side. Now that's false. Yes. But we still have to add those terms on the right-hand side. What do we get on the right-hand side? 49. So now I'll say yes. Yes. I complete the square with x. I complete the square with y, and I have a positive number on the other side. It's definitely a circle. Can anyone identify now the radius other than Vinny? And the coordinates of the center and the radius. Maybe I should start other than Vinny. Can anyone? The radius is? Yes. The square root, you mean?
Yes.
Good. That's the r squared, remember? Good. And can anyone give us the circle? The coordinates of the circle, of the center? Yes. Very good. Comma? Indeed. So that's when we started completing the square. One more time. The middle coefficient divided by 2, square the number, and add that to both sides. Yes. Sorry, but that's why I tortured you with the method last time when we worked on it. 63 now. We are ready for 63. So 63, same page. X squared plus y squared plus 3x minus 2y minus 1 equals 0. Looking at this problem and the previous one, do you understand why I did not want to start with this one?
No.
Here's why. This is not divisible by 2, so we're going to work with a fraction. That's why I wanted
I
to.
wasn't picking one with the fraction.
That's why I wanted. Yeah, that's fine. So that's why I wanted to show this after reviewing with the first one. Okay. So is this a circle? Does this equation represent the equation of the circle? The answer is no clue. I have to do work till I conclude yes or no. So then, let's complete the square for this and this. Middle coefficient. Divided by 2. You have to say 3/2. Square 3/2. Very good. That's what we have to add to both sides. Now this and this and this. What do they form? What perfect square do they form? Say it again. X plus 3/2 squared plus, let's look now at y. Middle coefficient. -2 divided, yes, -1 squared. -1 squared is? Excellent, awesome. So now this and this and this plus what? Yes, but it's minus because the middle coefficient is minus. And now on the other side we have 9/4, we have 1, and we bring another one from here, this one. This one goes to the other side. So 9/4 plus 2. The least common denominator is 4. And what do we have in the numerator? 17 indeed. 4 times 2 plus 9. Is this the equation of a circle? Yes, it is. Why? How do I know? Because I was able to complete the square with x, just x and a number. Or no number, but just x, y and a number squared, and a number on the other side. Can anyone give us the radius of this circle? No approximation. The square root of 17 divided by 2. Can anyone give us the center of the circle? -3/2, comma 1. This particular type of problem, type 3, will be more or less of an extra credit. I'm not going to ask you. I just want you to see it. It's not a difficult problem. If you remember how to complete the square for quadratic equations, you should have 0 difficulties here. Okay. The next chapter has quadratic functions, which we know everything about, but I will start from scratch. That's section 3.1. Section 3.2, polynomials and their graphs, something totally new, requires attention and work. We do not cover 3.3. Do we cover 3.3? Yeah, we do cover 3.3. Yes, we do. 3.3 we do, but not 3.4. Yes. The zeros of polynomial functions we do not cover 3.4, but yes, 3.3. So we have 3.1, 3.2, 3.3, and the last section is 3.5. And 3.6. Yes, and polynomial irrational inequalities.